Okay, so today is the last lesson for trigonometry. We'll do some review tomorrow, and on Wednesday you guys have your test on trigonometry. So I'll give you the review assignment today in case you want to start working on it, because it's always due for marks. That'll be due on Wednesday on the day of your test. So we did some questions on Friday dealing with multiple triangles, so we'll just continue our work today with working with multiple triangles. Remember, you can only use SOHCAHTOA if you have a right triangle. So you have to have a 90-degree angle in the triangle that you're using if you're using SOHCAHTOA or if you are using Pythagorean theorem. So this first question wants us to find the length of BC, the length of the side that goes from B to C, which we'll label as X. Right now, we only have one really piece of information in that triangle that we can use, and that is that 49-degree angle. We need at least one other piece of information. We need at least one side of that triangle. And we can find the length of BD using the triangle on the left. Using the triangle on the left, we can find BD, which I've labeled as Y, and then once we have that, we'll be able to find X. So, if I want to find the length of Y in that triangle on the left, I start by labeling the sides. The side across from the right angle is the hypotenuse. Because we're given that angle of 26 degrees, the side across from that is the opposite. The third side is the adjacent. So we always start by labeling the sides of the triangle. And in this case, we're going to use the opposite and the hypotenuse. We're trying to find the opposite. That's what we labeled Y. We're given the hypotenuse. And if we use SOHCAHTOA, the SO part, tells us that we would use the sine here, because sine is the ratio that uses the opposite and the hypotenuse. Those are the two sides we're using here. The sine of the angle, which is 26 degrees, equals, and again, the SO part tells us it's O first, H second. Opposite on top, hypotenuse on the bottom. Then we make both sides a fraction, so we can cross multiply. 1 times Y equals 22.9 times the sine of 26 degrees. So we go to our calculator. It's in degree mode. 22.9 times sine of 26. And if we round to the nearest tenth of a centimeter, that would be 10.0. The digit in the 10th place is a 0, and because to the right of that is a 3, that means that 0 stays the same. And that would be in centimeters, because that is what unit is used on the hypotenuse. So now that we have that side, we can now find what we really needed, which was X. And so we go back to labeling the sides of the triangle. So this X is the side across from the right angle. We're going to use the 49-degree angle. That's the angle in that triangle. Remember, you can never use the 90-degree angle with SOHCAHTOA. It has to be one of the other two smaller angles. And the side across from 49 is the opposite. The third side is the adjacent. And so in this case, we are going to use the opposite and the hypotenuse again. But it's a different triangle, and it's a different angle. But the ratio will be the same, because only sine uses opposite and hypotenuse. The angle is 49 degrees, though, because now we're using a different triangle. And the SO part tells us that it's O first, H second. Opposite on top over hypotenuse on the bottom. Now, I didn't write what the opposite was. We just calculated it to be approximately 10. So we'll put that in there. 10.0 divided by the hypotenuse, which is x. Okay, we found the length of y in the previous equation to be 10.0, which was a rounded value. Make both sides a fraction, so we can cross multiply. We'll get x times the sine of 49 degrees equals 10. And now we'll divide both sides by sine of 49 degrees. And I've said this many times, it's important to keep numbers in your calculator. We only round off our final answers, and that value of 10 that I rounded is in my calculator. And I get my answer for x by dividing that number, which I'm keeping in my calculator, divide that by the sine of 49 degrees, which gives us 13.3 as the answer. So there's our final answer for what we were looking for. Now, just to see if it makes a difference, if I just use 10 instead of the entire decimal, if I just divide 10 by the sine of 49, let's see if it makes a difference. And in this case, it actually doesn't. If you round to the nearest tenth, you'd get 13.3. But we've seen examples where that does make a difference. Rounding does make a difference sometimes, so just to be safe, keep numbers in the calculator. Okay, so looking at the next question. Find the measure of angle F to the nearest degree. So this is the angle theta that we're looking for. Right now, though, we don't have enough information in that triangle. All we know is that this side at the bottom is 9.6 centimeters. We do know this angle is 90, but that doesn't help us. We have to find one other piece of this triangle. And so what we can find is we can find the length of EG, which I'll label X, using the triangle on the left. Because the triangle on the left, I've got an angle plus one side. I can use those to find the length of X. But we start by labeling the sides of the triangle. The side across from the right angle is the hypotenuse. We're given that. We're going to use the angle of 34 degrees. The side across from that is the opposite. The third side is the adjacent. Always label the sides of the triangle the same way. And so in this case, once again, I'm going to use the opposite and the hypotenuse, which is the sine ratio again. The sine of the angle of 34 degrees equals the opposite, which is x, over the hypotenuse, which is 14.4 centimeters. Make both sides a fraction so we can cross multiply. 1 times x will equal 14.4 times the sine of 34 degrees. (14.4) times the sine of 34, which if I round to the nearest tenth would be 8.1 centimeters, because that's a unit that the hypotenuse is in. That is the length of x, 8.1. So now I can go to that triangle on the right to find out what theta is. In relation to that angle theta, the 8.1 is still the opposite. The G angle is 90 degrees. The side across from that's the hypotenuse. The third side is the adjacent. So in this case, I'm going to use the opposite and the adjacent. I found the opposite. I was given the adjacent. So to find theta, I'll use the opposite and the adjacent, which is the tangent ratio, the tangent of theta. And the TOA part tells it it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. And so as we've seen, if we want to find out what theta is, It's found by going tan to the negative 1 of 8.1 over 9.6. On most calculators, that's using second function tan. And again, I'm going to keep the entire decimal in my calculator. So in my case, I can go second function negative to get the previous answer. If you don't know how to do that, then actually type in 8.05237781. That decimal divided by 9.6. So to the nearest degree, it would be 40 degrees to the nearest degree. Let's see if it does make a difference, though, if we don't use the entire decimal. If you just go 8.1 over 9.6, let's see if it does make a difference to the answer. And in this case, it doesn't. But sometimes it will, so we always use the entire decimal. We've seen cases where it does make a difference. Number 3, for some reason, Jason is lying on the ground midway between two trees that are 100 meters apart. So because it's midway, that means he is 50 meters from each one. And that's important. The angles of elevation to the tops of the trees are 13 degrees and 18 degrees. That's in the diagram. How much taller is one tree? It'll be tree 2. The angle of elevation is greater, so that means that tree is higher. So we want to know how much taller is tree 2 compared to tree 1. So we have to find the height of each tree. And we'll start by labeling the sides of the triangles. The side across from the right angle of tree 1 is the hypotenuse. The side across from the angle of 13 degrees is the opposite. The adjacent side would be 50. And again, we want to find the height of the tree, which is the opposite. So if we want, we can put an X there. So we're going to use the opposite and the adjacent, which is the tan ratio. And the angle I'm using for tree 1 is 13 degrees. That's the angle of elevation. Tan of 13 equals the opposite, which is X, over the adjacent, which is 50. I'll make both sides a fraction so I can cross multiply. 1 times X equals 50 times the tan of 13 degrees. So when you cross multiply, you have X by itself, so we can just go straight to our calculator and multiply. 50 by the tan of 13, which is 11.5 meters, because that is the unit for the adjacent side. I'm going to store that number into my memory. Right? If you don't know how to do that on your calculator, you should write down all those decimals, 11.54340956. So now we're going to the triangle on the right for tree 2. The side across from the right angle is the hypotenuse. We want to find the height of tree 2, which we'll label Y. That is the opposite side, because it's across from the 18-degree angle. And again, the base, 50, is the adjacent. Just like the last one, we're going to use the opposite and the adjacent. We're not using the hypotenuse for either of these. We're not given them. And like the last triangle, the tan ratio uses opposite and adjacent. Only now the angle is 18 degrees. That's the angle of elevation in that second triangle. And the total part tells it it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. Make both sides a fraction, so we can cross multiply. 1 times y equals 50 times the tan of 18 degrees. So that gives us 16.2 meters. And the difference in the heights is found by subtracting those two. And again, I rounded them to write them down, but I'm going to use the numbers in my calculator. So I'll write difference here for the difference in the heights. So that decimal, take away the previous one. Whoops. Let's try that again. Minus alpha A. So that gives us 4.7 meters. That's the difference in the heights between the two trees. So all the ones so far have been two different triangles. With number 4, though, it's one triangle inside of another. And we saw questions like this on Friday as well. The angle of elevation of the top of a tree T is 27 degrees. So that's in this diagram here. That's the smaller angle. From the same point on the ground, the angle of elevation of a hawk H flying directly above the tree is 43 degrees. So that's this larger angle. If the tree is 12.7 meters tall, how high is the hawk above the ground? So to do that, we're going to have to use the large triangle QHG. But the only thing we know about that large triangle is that this angle here is 43 degrees. Yes, it's true, the angle at G is 90, but we can't use that in our calculation. What we're going to do here is we're going to find, using the smaller triangle, we're going to find the length of QG, which I'll label X. That is the base of both triangles. Both triangles share that side. And using the smaller triangle, the angle of 27 degrees and this 12.7, we can find out what X is. And then we can use that to find out what the height of the larger triangle is. But we start by labeling the sides of the triangle. The side across from the right angle is the hypotenuse. The side across from the 27-degree angle that we're going to use is the opposite. The third side, X, is the adjacent. And in this case, we're going to use the opposite and the adjacent, which is the tan ratio. The tangent of 27 degrees. That's the angle in that small triangle. And again, the toe apart tells it it's opposite first, adjacent second. Opposite on top, over adjacent on the bottom. Must be in that order to get it correct. Make both sides a fraction so we can cross multiply. So X times tan 27 equals 1 times 12.7. And we can put M for meters there because that is the unit. And then to get X by itself, in this case, we need to divide both sides by the tan of 27 degrees. So that'll give me X by itself. And 12.7 divided by the tan of 27. Whoops. I forgot to put the tangent of 27. Is 24.9 approximately meters. So that is X, the base of the small triangle, which is also the base of the larger triangle. So now I want to find the height of the larger triangle. I want to find HG. I really only want to know what HT is, how high the hawk is above the tree. But HT is not a side of a right triangle. So I have no choice but to find out what HG is, which I'll call Y, and then I can subtract the 12.7, which is TG, away from Y, and that'll give us what I'm really looking for. How high above the tree is the hawk? So I want to find Y. Again, the side across from the right angle is the hypotenuse. I want to find Y, which is the side across from the 43-degree angle, so that's the opposite. Again, x is the adjacent, which I'm going to use because I found it. Once again, I'm going to use the tan ratio because that uses opposite and adjacent. But now the angle is 43 degrees. And that'll equal the opposite, which is y, over the adjacent, which I found to be 24.9. That number is in my calculator. So when I cross multiply, 1 times y will equal 24.9 times the tangent of 43 degrees. So 24.9, which I've got on my calculator, times the tangent of 43 is approximately 23.2. And so the height of the hawk is the difference between the 23.2 and the 12.7 that we were given for the height of the tree. So the height of the hawk, which is what we're trying to find, that's HT, is the difference between 23.2 and 12.7. So again, I've kept that entire decimal in my calculator, and that gives me 10.5 meters. How high the hawk is above the tree. Okay, so again, your test is Wednesday. I'm going to hand out the assignment, today's assignment, that I'll post the solutions to Google Classroom so you can check your answers. I'll also hand out the chapter review. If you want to start working on that today, you can, because these are always due for marks. So tomorrow we'll go through the quizzes that we did. I know some of you have still to write some of those, so I'll get those to you today to write. We'll go through those quizzes tomorrow, and then you'll also have some more time to work on the review assignment for your test on Wednesday.